Hello students and welcome to part 2. In this part we are going to look at one more basic example and then we will look at two real-world formulas that you can practice rearranging and summarize our learning. So here we are on example 4. We have y equals 3x plus 9 and we're solving for x. So we can create a do and undo chart for this equation. If we look at the variable that we are trying to isolate, we can see that it's being multiplied by 3 and then 9 is being added to it. So to undo it, we'll have to subtract 9 from each side and then divide each side by 3. So we'll start by subtracting 9 on each side. 9 minus 9 makes 0, so we have 3x plus 0 is just 3x. And on this side, we have y minus 9 because y and 9 are not like terms, we cannot combine them. Last, we'll divide each side by 3. 3 divided by 3 makes 1 or 1x. We get x equals y minus 9 all divided by 3. So this is shared division. Now remember, when a coefficient does not have a number in front, that's really a 1. So this is really 1 divided by 3, or 1/3 at y, 1/3 y, and negative 9 divided by 3, which is minus 3. So this equation is x is equal to 1/3 of y minus 3 more. Now, let's look at a real-world formula and rearrange it to get a glimpse at a different variable in the situation. So this example says, reverse the formula for Fahrenheit temperature in terms of degrees Celsius. In other words, solve for Celsius in terms of Fahrenheit. So if we look at Celsius, which is here, we can see that there are two operations acting on the Celsius variable. The Celsius variable is being multiplied by 9/5 and 32 is being added to it. So to undo that, the opposite of adding 32 is to subtract 32, and the opposite of multiplying by a fraction is to multiply by the reciprocal. So the opposite of multiplying by 9/5 is to multiply by 5/9. So we'll start by subtracting 32 from each side. 32 minus 32 makes 0, so we're left with 9/5 C equals F minus 32. These are not like terms, so we'll just have to write Fahrenheit minus 32. Then we'll have to multiply each side by 5/9. 9 divided by 9 makes 1, and 5 divided by 5 makes 1. So we're left with just C, since we have 1 times C. But when we multiply this whole side by 5/9, we'll also have to multiply this whole side by 5/9. And I'm going to have to use parentheses because there are two terms being multiplied by 5/9. So C is equal to 5/9 times Fahrenheit minus 32. So we get Celsius equals 5/9 times Fahrenheit minus 32. Did you know that there is a formula for your typing speed, how fast you can type on a keyboard? Here's the formula. S equals W minus 10E all divided by M, where S is the speed in words per minute, how fast the person can type, W is the number of words typed, E is the number of errors they made or mistakes, and M is the number of minutes typing. What we are going to do is we're going to solve this equation for the number of words typed, or the W. So let's begin by making a do and undo chart. Solving for W. So we can see that the first operation occurring is W minus 10E. So the first part in our do will say minus 10E. Then, after we would subtract that, we would have to divide by m. So to undo that, we'll have to multiply by m and then add 10e. So our first step is we're going to multiply each side by m. M divided by m is 1. So get w minus 10e is equal to m times s, or ms. You can just touch each other instead of writing a time symbol. Now our second step is we'll have to add 10e to both sides. Negative 10e plus 10e makes 0, so we get w equals ms and 10e do not have the same variable, so we cannot put them together, so let's put ms plus 10e. So w is equal to ms plus 10e. In other words, they would have to multiply the number of minutes times the speed and then add 10 times the number of errors. Now let's summarize what we've learned. We've learned that a literal equation is an equation with two or more variables. We've learned that an equivalent equation can be created by solving a literal equation for a given variable. And to do so, there are 3 steps. First, locate the variable you are asked to solve for in the equation. Second, identify the operations acting on the variable and the order in which they are applied. In other words, fill in the do side of your do and undo chart. And last, use inverse operations to isolate the variable. Complete the undo side of the equation and carry out those steps.